Hi, welcome to this lesson on number patterns, infinite geometric series. Let's have a look at question 1 on solving an infinite geometric series problem. We are asked to calculate the value of this series here. 1 plus a half plus a quarter plus an eighth all the way on. So how do we know this is a geometric series? Is it of the form Tn a times r to the n minus 1? Well, let's see. The first term a here is 1. And to get to each next term, it looks like I'm multiplying by a half. So I would say my common ratio here, r, is a half. So we want to find this infinite series because you can see the plus dot 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 indicates you want to find the sum to infinity. So recall the formula, it's a over 1 minus r. But we can only use this formula under a certain condition. What is that condition? Well, that holy grail condition was that your r value, the common ratio, must be between 1 and negative 1. If you ever have issues remembering does your r value lie between here, think of it visually. Draw yourself a number line, put negative 1 and 1, and ask yourself, well, where does r equals a half go? Well, here's 0 in the middle, and half is in the middle of 0 and 1, so it's here. So it's definitely within this interval of convergence. So it does converge here. So you can say, since r is between negative 1 and 1, r is a half, the s to infinity exists, okay? Because that means that your r value, your constant ratio, will make this infinite series converge, okay? So all I have to do is plug in the values. A is 1, r is a half, so therefore I get 1 over 1 minus a half is a half. Remember, 1 divided by half is the same thing as saying 1 times 2, right? When you divide by a fraction, you multiply by the reciprocal. 1 times 2 is 2. So that is that infinite series. And you can sort of see that that makes sense, right? So if you look on your number line, let's visualize it for a second. I'm going to put 0 here, I'm going to put 1 here, I'm going to put 2 here. You're starting off with 1, so you've added 1 unit. Okay, so you've traveled a distance of 1 unit. Now you're adding a half. So a half will get you to 1 and a half if you add a half more. Then you're adding a quarter. So if you're adding a quarter, so between 1 and there, so if I break up this interval here into quarters, 1, 2, 3, 4, so 4 quarters, then I'm traveling 1 quarter more. Then the next term, so within this new interval here, I can break that up into eighths. All right, 1, 2, 3, 4, 5, 6, 7, okay, eighths. And if you break them to 8, you're only traveling on 8 here. So if we keep doing this, breaking up into sub-intervals, we're going to keep moving a little distance more, little distance more, little distance more, little more. And you can see you're getting closer and closer. You're converging to the number 2. So that's how you can visualize it geometrically using a number line as well. Okay, so that's what the infinite geometric series is doing here. We know it exists because the constant ratio r satisfies this golden property. Okay, and we can just use the sum to infinity formula to find what that exact value is if we added up all the terms infinitely. Okay, I'll see you in the next one.